I expect while you can start directly on this lecture, you would have seen the earlier lectures, at least the summary part of it towards the end of what we have covered and all this. This is part of the course covering how to convert an idea mostly electronic into a circuit, which you generally you can do the analytical part and you can probably verify various things which are there on the internet, various resources that are there on the internet, and eventually make it into a product that will have a unique appearance or a physical existence for it. A circuit is still just an interconnection and something which proves a little bit of your intent and various options about it. But then a physical product has to exist in reality with a harsh environment. The environment can still be benign as it is when you use carefully by a trained technician or by yourself or a single operator, and extremely harsh where it could be dropped. Intentionally it is kept underwater, intentionally it takes a lot of beating and so on. But that is more towards another 4 or 5 lectures away from here. So far I have been covering things which are a little related to what our students have been doing here in our department for the last about 25 years. So now looking at my this presentation, I went through in detail about this, a device for us to check or calibrate an auditorium, and very rarely of course what teachers would like to do, very rarely is the teacher adjusts his level of speaking. Intellectual, of course, yes, students are much more intellectually superior, or whoever the knowledge seekers are superior. This is only about the audibility at the back of the thing. Now, one of the important thing is a sound level and comprehension are not about the same. Something in between is called the volume units. Volume units are nothing but sound pressure level which has been adjusted depending on a human voice, and typically again you have various curves which talk about frequency versus level, and there are threshold curves and curves which are of equal loudness about it. So, this is supposed to have VU meter. Volume units are slightly different from the other meter. So, this I had explained to you in detail. Next project, this is eventually this whole concept here, you will notice that there is a there is this beautiful concept, and then it has been implemented. You see, we have a product which results from this, and in this case it is organic also. So, I have taken you a very extreme example. I will take you to other examples which are commonplace. This particular thing, of course, it has a little problem from the legal point of view. One of them is that over here in India we use bottled LPG, that is liquefied petroleum gas. The problem about any liquefaction is that very rarely the pressure changes. If you take I will try to draw a picture of a bottle here. This is typically how LPG bottles, or in our case we call it a cylinder, are used on the environment. Sometimes it is under the they call kitchen counter, sometimes it is outside the thing. The issue being that there is no way of fitting a simple Bourdon gauge or equivalent meter which will tell you how much of gas is remaining, because any time if this was the level of the LPG inside, this part will be the gas, this part will be the liquid, and it is filled under a pressure which will ensure that you have a constant supply. And then this device which is there on the top is called a regulator, and this regulator ensures that the pressure which is there is lowered a little, and then it is supplied to the cooktop, or in our case now we call it a burner. So, as such this pressure is constant all the time. Only thing that does change is the level of this, and then consequent to this level we have the total what you call volume and a quantity which is proportional to this, that is I will call it here weight. Let me not go into the thing about saying is it kilogram force and I use newtons and why all that, because over here we just go by kilograms directly. That is what everybody understands, and I think some part of the world they have the pounds, and then I do not know other places. The issue being, as the gas is consumed, the weight changes. That is the only physical parameter that can be easily reliably measured. There are other things also saying this meniscus is usually a little cooler than the ambient because evaporation keeps taking place here. So, there are LCD strips. If you stick the strip on the side and all that, it is okay. I mean it is supposed to indicate the liquid level. So, coming back here, one of the students has come out with a concept which is also existing, but incidentally it is not allowed in India saying why do not we have a balance here, an electronic balance, and this electronic balance has the various what do you call things inside to sense the weight of the cylinder, and then it transmits to a display unit here. This display unit can be put in a place where the cook can see it either all the time or only when you query it. You can put it whenever you want, you can just see the display, like you press a key. Imagine if this were the display. So, I press a key and then I get dots on it, otherwise it goes to sleep. In principle it is very good, absolutely no issue about it. Plus if you look at my slide again one more time, you will notice here that it has a beeper here. That beeper can indicate you it is the preset time. Yes, that was a blooper, it was a preset amount of liquid that is remaining. Just like in a battery you have a depth of charge or depth of discharge, we can have something which shows there. And then we have several other things, we have a knob here to do various functions, and then a set of LEDs here. You see the way the display has been arranged, they are discrete because it is easy to make them. And then at the top level you have green, and the middle level you have amber, and the bottom you have the dreaded red, a little like what you have on a traffic intersection. Well, the going is good and the things are easy. This is how inside things look like. You see here we have a beautiful battery. This is a 9-volt 6-cell battery, and then you have a printed wiring board. And then the way these things have been made, the moment you open the cover, it is easy. We can go ahead and independently test this device. You can put it here and nothing is attached, which is why I wanted to show you here. This is fully testable. There is nothing which is hanging around what you call, there are no wires attached to this. And then if you see these what you call two cells also, the cells are probably attached to this either by a separate what you call small jump cord, or they can be part of a battery door here, and then you have clips. So, those clips will, I will try to erase it and start. If you ever used this 9 volts battery, I think you will know what I am talking about. So, it is possible for me to use them in series, get a little higher voltage, or alternately I can use them in parallel. And then there is a small connector wire which is there. So, I attach this here and I attach this here, and then I am in business. It is not very difficult to make. Making an enclosure like this is not very easy. And then subsequent lectures I will cover about how to use a standard enclosure for this. So, this is how it is expected to see. Now, slowly, can you see some elements of, I will call it good and bad. Good is it is implementable. This particular thing was a load cell, okay. It is a beam with load cell which is available in the lab which our students are working. You do not need all that right now. You can probably have a tray on which you can do it here, and then you see this beautiful look of this what do you call device that is there is more to scale. It also looks a little like the LPG bottle. There is a safety ring here, there is something here to hold it, and you can also use it like a handle, and then it looks a little like the LPG bottle. So, in principle we have a beautiful product. If we want, we can connect wires, otherwise we can make it wireless. In this case, what they have done, discretely they have taken wires from this, taken them out and then brought them here, and then they have connected them here. Later on, after a little while, I can even see it, it goes here like this and comes. It has been found out that anything where a potential can exist here is banned by safety regulations. So, this cannot be done. So, something else has to be done. We can probably make a flame proof or explosion proof device which can be connected wirelessly to this. And how do you get power from it? It should not be powered, we have to use some gift power system, saying we try to do a little bit of energy harvesting as and when we need it, or it can be a passive RFID device, like if when I switch it off, I switch off the gas and turn off the regulator, take this and put it near and read the RFID value and all, which is a little like the small tokens which are issued when you want to enter the metro railway station. You have a turnstile and you have this token which I was showing you yesterday, that has all the information. It is not very big, and the moment it is inside, it does not cost you anything, which will take me to the next few slides. You see here somebody was working on that same lamp which I tried to show you yesterday, saying why does it have to look ugly, why not something. You see here they have got a beautiful, I felt thrilled about it, saying why can't we have something like that. It should look like a, I do not know what is that object, would I call it an egg, or else it is a very friendly stress busting thing. You can even hold it in the hand, maybe it is soft enough, you keep on like that sponge devices you have. And this one, the other extreme, saying it looks a lot like a different object. Then you have something here which looks like a cone, and then there is something here which looks like something else, part of it, and maybe they can be stacked, maybe this goes on top of it here. They have made it finally. See, this is where the beauty is. These are all the concepts which they have worked out using, yes, it is written, I can't bluff, it is written using some illustrated package. In our case, on our premises, most of the packages have the student licenses or number of places or seats, as such our students have access to it. Then you see here all the features which are there, and then you can use it, and then you see here what all, you see the color and you see all the various objects, after you take it out, it just, what do you call, stays there without falling off. So, you see here there is a blue, this is one combination, and then you see there is a red combination, and the most important is it is self explanatory that you have a dovetail and then you keep it underneath this. You can use it like that. In case you do not want it, you can probably, you can use it as a torch and emergency light. I will now come to the next to this thing. You see here, I do not know why they call it a glomp. There is some reason for it. I will check with them and get back to you. Oh, they have a beautiful origami based transmitter and receiver. I do not know what that this thing is, except that this being an open what do you call environment, and people can try out their various options. Somebody has come out with a device. I do not know whether it is a remote or it is a what you call forget me not aid, or it is a docking system or anything. So, once when I asked the student, he explained to me that the transmitter is kept in his bag, and then he has this receiver. One of them, which is larger, is carried around. The smaller thing is kept in the place which needs the what you call, I will call it anchorage. Instead of loosely tying it with a cord like this, you see here, I have a huge cord here. Well, it is all right, absolutely no what you call no problem about it. We have a serious problem often, no, people walk away with it. I wish somebody made a device which will beep me, or even what you call zap me, or even maybe you have the other more violent devices to control me, to make sure that they are not separated beyond a distance. The moment it crosses a distance, if I get a beep, I know that I am what do you call, I am going beyond the thing. So, it is one of those devices. In this case, because they had to make sure that they have the thing already, they tried to make it a little big, but the scale is not known here, no, it has it. This I had explained to you a lot yesterday. We have more and more beautiful devices. So, it was also submitted as part as a what do you call a device for part of this rapid prototyping. So, you can see it again, the good old Watchdog. I avoided mentioning the whole thing as to why it is called a Watchdog. In the case of our microcontrollers and all that, we have a small issue about it, saying let us say use it in a critical situation where monitoring is very, very important. Imagine we have one of these small microcontroller devices which is attached to a patient monitoring system. What if the microcontroller itself fails? So, we do not know whether it is a, so we have 4 conditions, something is true, something is false, true, and then we have false. Okay. The condition is it is to be displayed, not to be displayed. So, we have this issue of what you call getting a proper thing. So, something called a watchdog timer is usually implemented in these devices. In case the code freezes, the watchdog timer is a little different level. I do not know if it is high or low, the way I do it, it takes control of it and saying there is no activity, and it's a parallel thing. As soon as there is no activity, we will be able to get an indication. So, that whole thing about the watchdog timer came to them about the saying nobody can disable it. The moment something happens and it loses power or anything, before that it also says it has failed. That is how the word watchdog timer was there. This slide I had shown you yesterday. I will come back to one of my favorites, this Lumi. And then the various things that have played out with that Lumi here. Product sketches, various operations. Now, let me take you back to a small device here. Oh, good old quill. And if somebody says it is a pen knife, they are not going to cut your pen, you can't chisel your pen with it. It all started with people trying to take various type of quills and they sharpen the end and then they dip it in an ink pot and then to start writing. Good concept, is it not? Our Lumi also is a little like that, except that here whatever what do you call my good intelligent and very perceptive students have said is, sir, it looks ugly, why don't you use something good? So we had this beautiful, very shiny, I do not know what it is. People tell me it is probably what is called a votive candle holder. Just check up what is nothing, is probably no, it looks like a fat candle holder and it looks a little like a crystal. It is actually a glass, it is just polished and then something from another object has been attached here on top. Then we put this. I have a beautiful quill device, looks a little like a quill, is it not? This of course is a novelty. The moment you look at it, you will think, good idea, the concept is good and all, it is practical and all, we will come back to later. The earlier pictures I have shown you were about it. So if you see here in the product sketches, people have spent a lot of time about how to make it look important. I have shown you that origami this thing. As I said, I have no clue what that device is, but then this student, no, he is fascinated by origami, and the beauty of origami is that they are all planes, and by simple folding we are trying to get objects. We have a boat, and then in this case we have, I think all of us know this, and then we have this beautiful small baby elephant, and then we have other various, I mean depending on how you do it, no. So he has developed on all these themes, saying let me make an object which contains the various objects in it, because he is fascinated by planes. But why a plane, just a plane, why not organic and why planes? One of the beauties here you will notice is, well, that organic structures are okay, they are not that easy to reproduce in case you want to make use of what is called either cardboard or sheet metal, because by definition a sheet is flat, and then any other modification involves different type of manufacture and all that. Making these things is very easy for us, depending on if you orient it properly and so on, no? It is easy for us to make a inclined plane and something related to it. Again I will take you back to my this votive candle stand. So if you see this votive candle stand, here you will notice that all these planes, can you see two of them are shining a little, they are all plane, by definition they are plane. And something by a very important thing, they are elemental triangles. The advantage of an element triangle is, in space if you are to have three dots, dot here, dot here, dot here, this can always be joined in a plane. Any three dots can be coplanar. I do not know the full mathematics, and then my apologies for my ignorance. And even if you take a mesh, all meshes are made in our computers exclusively by breaking them into triangles. So the moment I have an object like this here, it is constructed of basic triangles, and the advantage of it is being planar, finishing it is easy. All you require is probably a flat surface, a little bit of pumice powder or related thing, then keep on ensuring something becomes flat. Making a cylindrical object like this is very tough. There is no simple way. By hand we can do it, they are experts. So people have to mount it on centers and then start rotating slowly and probably make this. So two geometric primitives, one is a cylinder or anything with a center which has got a axis of rotation, and other thing, a flat plane can always be polished easily. So, this student went around playing with this flat plane. So, he says origami. I like it. I enjoy these things. Now, coming back to the next thing, this is also one of the exercises I would like to give. Why can't you make a torch? Torch looks simple, but then they keep coming more and more and more, and suddenly you see that there are torches and torches, and when you go to medical, you suddenly have all the sorts of endoscopes, then you have keyhole surgery devices, then you have something which you send through the various places here and then try to see inside. So, if you see, all of them have two parts of it. One of them the illumination source, the other part is the actual place where the the area to be illuminated, various operations, and so there are torches and torches and torches. I have about 200 samples of these. I will see what I can show you in due course. So, the student, when he played around, he says the last torch has not been invented yet. A simple cylindrical thing, as long as it is short, it is okay, but if it were long, obviously better form is required. So, he has made one here, the same thing is kept lying flat here, and then he has made something. To me, it looks unusual, that is all I can say. So, I will stop here